Alrighty, well, some of these were a little easier. Number 4 was probably the most challenging problem. Well, the perimeter means the distance around the outside, and you're given these little geometric markings, which implies all three sides are congruent. So this is an equilateral triangle. So to get the perimeter, just multiply 7.39 by 3. Right? Now the second problem, question 2, it says this is an equilateral triangle, so that means the sides are all the same. So if they give you one side with the expression 4x plus 7, and then it says another side has an expression 3x plus 8, since this is an equilateral triangle, those two have to equal each other. And then once we find x, we can figure out how long each side is by substituting x into one of these expressions, and then we'll be able to find the perimeter. Okay, so we're going to solve this equation. All right, so that we can see that x is 1. Okay, and if you put the 1 here or you put the 1 there, either way you're going to get 11. All right, so this is an equilateral triangle with a side of 11, so add the 3 sides, you get 33. So we solved the equation based upon the geometry because the two sides expressions have to be the same since this is an equilateral triangle. And then once we get the value of x, we can actually find what the length of the side is for the equilateral triangle. Either expression will do. And then now you can get the perimeter. All right, and then the third question. Okay, we know this is an equilateral triangle and we have a rectangle. So they're telling you that the perimeter of the equilateral triangle is equal to the perimeter of the rectangle, but they only give us the dimensions of the rectangle. All right, so we want to find some kind of equation that will help us get the length of one side of the rectangle. All right, so let's go ahead and label our variable the side of the rectangle. And we're told these two perimeters are the same. Okay, so that means 3x has to equal the perimeter of the square, which is 18. And then you divide and problem solved. Now it's the number 4 problem that's a little tricky. And that's because notice that there's a lot of sides that are the same by these two tick marks. And once they tell you the measure of DC is 14.1, that means these other two sides are 14.1. And so right now it looks like we have two isosceles triangles based upon the geometric tick marks. Now the isosceles triangle on the left, they give us this angle here. And remember, an isosceles triangle, there's two angles that are congruent. The third one is different. Well, the one down here at C is going to be different. So this other angle up here at A is 30. Okay, and that's the tricky part, knowing that that's the property of the isosceles triangle that helps us. All right, now we can get the angle that is different in the triangle because we know two angles, so we can get the third by subtracting from 180. We can get this one by doing 180 minus 30 minus 30, which is 120. All right, well, if that's 120, then the supplementary angle on the right, which makes a linear pair, is 60. We know this is 60. Okay? Now we also knew that was isosceles. And if that's isosceles, that means the two angles here and here have to be the same. Okay. Well, subtract from 180 and then divide by 2. And that tells us right now, oh, wait a minute, all the angles are 60 degrees. So this has to be an equilateral triangle, which is the key to this problem. All right, well, if we want to find the perimeter, we need to know that side on the top left. And if you look at these two corner angles, 30 plus 60 is 90. Oh, okay. So now what we got is we've got a problem where that's a right angle. That's 14.1 because that's the little tick mark since the equilateral triangle. And on the bottom, we got two 14.1s. So what we want to find is we want to find that other side I'm going to label A. Okay, again, that's the tricky part of this is realizing we have a right triangle. Realizing that 60 plus 30 is 90. So now we can use the Pythagorean theorem. And then we can finish it from there. All right, so to recap, since the left triangle was isosceles, we knew we had two 30s. The angle that was different would be here, and we could find that angle by subtracting from 180 the two 30s. Now it's 120. And now we can find the angle on the right because we have a linear pair. And so we can subtract from 180 again. So now we have an angle in the right side triangle here, which is also isosceles. And so to find out the two other angles, we would subtract from 180, divide by 2, and that got 60. And once we knew they were all 60, we knew that was equilateral, which meant that side has to be the same as the other two. Since 30 plus 60 is 90, we have a right triangle. And so now I redrew the diagram. We need to find the third side so that we can get the perimeter. And so that since that's a right triangle, you can solve this problem. Okay, and then you would add those three sides to answer the question. Okay, again, that one was definitely tricky. All right, and this one wasn't too bad because since you know two angles are 60, that means the third one has to be 60. So this is equilateral. And since you know one side's 26, that means the other two sides have to be 26. So just real subtle application here. So for number 5, you would just solve two equations to get the x and the y. All right, so you would just solve x plus 6 equals 26, and y plus 3 equals 26. Okay.